In this lesson 5.8, we are going to learn how do we solve integrals involving inverse trig functions. So when we look at one integration, if we have square root in the denominator, or u times square root, or a squared, the sum of two squares, in this case, we might need to use the inverse trig function. Based on the derivatives we learned in 5.7, the inverse sign gives you 1 over square root of a square minus u squared. Okay, so now we are taking the antiderivative. Let me show you some examples. So for me, it's easier. When I see these type of problems, I'll change the coefficient of u squared. I'll change it to 1 first. For example, example 1. So I can rewrite this as 1 over square root of 5 squared minus x squared dx. In this case, my a value is 5. So this will be sine inverse x over 5 plus c. If you look at example 2, so a value, so a equals 3. So this will be 1 over 3 tangent inverse x over 3 plus c. So if you look at this one, our a value, the coefficient of x squared is 1, a equals 4. So it's 1/4 secant inverse x over 4 plus c. When we take the antiderivative, we don't have cosine inverse, cosecant inverse, or cotangent inverse because there's only a negative difference. So we only need to know these three. We don't need to use the rest three trig functions. So let's look at this one. This one, the coefficient of x squared is not 1. So for me, first, I'm going to factor the 4 out. So it's 25 over 4 minus x squared. So now I take the square root of 4. So 10 over 2 times square root of 25 over 4 minus x squared dx. So first I make sure the coefficient of x squared is 1. Now 10 over 2 give me 5. I can write down 5 outside. 25 over 4 minus x squared dx. So after I write this down, this I know it will give me sine inverse. But a squared in this case is 25 over 4. So a equals 5 over 2. After I solve for a, so this will be 5 times sine inverse x divided by 5 over 2 plus c. So it's 5 times sine inverse 2x over 5 plus c. That's my final answer. Let's look at example 5. So example 5, the coefficient of x squared is not 1, and there's no square root. And if you look at this is a square plus another square, so our answer will be tangent inverse. So first, let's take care of 9 first. I'm going to factor 9 out. So 7 over 9 will be moved out. Integration 1 over 4 plus x squared dx. In this case, a value equals 2. So our final answer, 7 over 9 times, don't forget 1 over 8, 1 over 2 times tangent inverse x over 2 plus c. 7 over 18 tangent inverse x over 2 plus c. Don't forget this number 1/2 here. Let's look at example 6. So example 6, I have an x here, I have a square root. So your answer will be secant inverse. In this case, so first we factor 16 out. So 16 out is 12 over 4x minus 49 over 16 dx. So it's 3 integration 1 over x square root of x squared minus 49 over 16 dx. So now we realize a equals 7 over 4. Okay, based on the formula right there, so this will be equal to 3 times 1 over 8. So 1 divided by 8, so it's 4 over 7 times secant inverse times x divided by 8. So it's 4 over 7x plus c. So in example 7 and 8, we are going to see how do we use substitution to solve some integrals involving the trig, inverse trig functions. So example 7, so it's the integration d of x square root of e to the 2x minus 1. So when we look at this problem, if we define u equals e to the 2x minus 1, when we take du, it's not going to work. However, we know e to the 2x equals e to the x squared. Now we are going to define u is e to the x. So du will be e to the x dx, which is u times dx. So now we are going to replace all the dx, which is 1 over u du. And e to the 2x minus 1 will become square root of u squared minus 1. So this will be 1 over u times square root of u squared minus 1 du. This is exactly our secant inverse of u over a. A is 1 in this case, plus c. Now we plug in u equals e to the x. So this is our final answer. In example 8, we look at the denominator, it's 1 square plus another square. So we might be able to use inverse tangent. However, in the numerator, it's not only x, we have some other terms. So we are going to use u substitution. U equals x plus 1. Du will be dx. From here, x equals u minus 1. We plug it in. So it's u minus 3 over u squared plus 4 dx. So now if you look at this problem here, in the numerator we have two terms. We have u, we have a constant. So now we are going to split this into two parts. So this is du minus 3 integration 1 over u squared plus 4 du. So the first one, u squared plus 4, we might need to use another u substitution. We call v equals u squared. dv equals 2u du. So this will become u du will be 1/2 dv over, so u squared plus 4 is easier, plus v minus 3. This one is directly inverse trig. A equals 2. 1/2 tangent inverse u over 2 plus c. So this one gives us 1 over 2 ln v minus 3 over 2 tangent inverse u over 2 plus c. Now we just plug v and the u in. So v equals u squared plus 4 and u equals x plus 1 squared plus 4 minus 3 over 2 tangent inverse x plus 1 over 2 plus constant c. So also sometimes we have to know how to use computed square before we applied the formula. If you look at this example, find the area of a region bounded by the graph here from x-axis and the line 3 over 2 to 9 over 4. So the area will be given by 3 over 2 to 9 over 4, 1 over dx. Of course, we know this function is always on top of x-axis. That's why we don't have negative values here. So if you look at this one, the inside we have a square root. We cannot use u sub directly. We are going to compute the square for the denominator. So it's negative x squared minus 3x dx. So first we write it into this form. Next, so negative x squared minus 3x. How do we compute the square? Okay, x squared minus 3x. We look at the coefficient. The x squared coefficient is 1. You have to make sure. And the coefficient of x is negative 3. So we add 3 over 2 squared minus 3 over 2 squared. So we divide by the coefficient by 2. So this one, we are going to combine the first three terms, give us x minus 3 over 2 squared minus 9 over 4. So this will be equals 9 over 4 minus x minus 3 over 2 squared. It's 1 over square root of 9 over 4 minus x minus 3 over 2 squared dx. So now you might need to use u substitution. So u equals x minus 3 over 2. So du equals dx. This is 9 over 4. So after we define u and du, so this will be 0. So 9 over 4 minus 3 over 2 give us 9 minus 6, so 3 over 4. 1 over square root of 9 over 4 minus u squared du. So this is a value here is 3 over 2 now. So sine inverse 2u over 3. U from 0 to 3 over 4. We plug everything in. Sine inverse 1/2 minus sine inverse 0. Sine inverse 1/2 is pi over 6. Sine inverse 0 is 0. This is our homework. So make sure you are okay with computer square.